What market conditions would force Walmart to stop selling barbecues in the short run? So this is the shutdown point. And the shutdown is when P is less than C. And so when P is less than 278, that's when you're going to shut it down, right? Because it costs 278 to acquire this barbecue, right? So the cost to Walmart is $278. If they can't charge more than 278, then they're better off not selling the barbecue at all. Right? So that's when they shut it down. As far as an answer goes, you just need P less than 278. Whew. Big profit function. Any questions about that one? No. All right. So this is where we get into simple interest. Back to test 2, I guess. And so both of those first 2 questions were from test 1. Oh, I forgot to write a little, what type of question? This is a CBP analysis, but I also call it just a profit function. Right. Profit function problem. Can't remember if I So for this next one, the type is just a simple interest problem. It does make use of the calculator, right? The days between dates function, as you can see. So I took out a series of loans, $4,000 on September 4th, 2004, a loan for $10,000 on December 12th, 2004, and a final loan for $2,000 on February 13th, 2005. What total debt do I owe on June 6th, 2005? So remember, for simple interest, we need to know the time, we need to know the rate. Time is just the time in years. And so we have to figure out, okay, how many days between each of these dates to get the accurate time. So this is where we started doing our timelines. Something like this. And we said, okay, well, we'll start by just figuring out how many dates, how many ticks do I have for these dates, right? So we've got a September 4th, a December 12th, a February 13th, and then I want to know the total on June 6th. So I've got 4 ticks. So I've got the 2 endpoints and then 2 in the middle. So I've got September 4th, 2004, December 12th, 2004, February 13th, 2005, and then finally June 6th, 2005. Oops. Now we've made so many timelines that this seems pretty reasonable, right? Just 4 ticks. And so remembering to put the dates up above and then the amounts down below. And so we've got 4,000 on September 4th, 10,000 on December 12th, and 2,000 on February 13th. So we want to know, how much do I owe on June 6th? That's what makes that the focal date. And so we're going to draw all of these payments to June 6th, right, to figure out, okay, well, how much do I owe with interest on June 6th? And so what I like to do is I like to take the amount that's closest to the focal date and draw that arrow first. That way the arrows don't overlap, but it really doesn't matter which arrow you draw first. Because I'm pulling this arrow forward, right, this is going to be a future value. And because I'll be calculating a couple of them, 3 actually, I'll just denote future value 1, future value 2, future value 3. So the total of those future values is going to be the total owing on June 6th. For simple interest, right, we said, okay, we're going to put the time on each of these arrows. We have to figure out the time, so the length of each arrow. So I'll call this one time 1, time 2, and time 3, just to match the future values. And so find the days between dates. So T1, remember the format for the days between dates function? It's month, month, dot, day, day, year, year. Month, month, dot, day, day, year, year. So for T1, I need date 1, I need date 2, and I'm trying to find the days between dates. And just as we've been doing, if the one, or for the one that I'm trying to solve for, I'll put a little star next to it, just to indicate that that's the one that I'm calculating. And so we're trying to find the days between dates. And date 2 for all of these are going to be June 6th, 2005. And so date 2 is going to be 06, 06, 05. Because T1 is for the one that's closest, right? That could be the only thing that trips you up, is February 13th, 2005. And so it's going to be 02, 13, 05. Remember how to use the days between dates functions? So the date function on your calculator is above the 1 button, so you need to go 2nd and then 1. And then it'll take you to date 1, and to change the date, you'll do 02.1305, and then to save it, you have to hit enter, and then it should change the format accordingly. And then scroll down using the down arrow to date 2, which is going to be 06.0605, enter. And then you can scroll down to the days between dates and hit the CPT button, which is the compute button. So compute this, and I get 113 days. So I'll put that on here. Time 1 is 113, and in years divided by 365, right? 365 days in a year. What you've probably noticed by now when you're working on your calculator right, is that once you've stored date 2, for example, we know it's not going to change. So now all you have to do is go in and change date 1, and then go to the days between dates and compute, change date 1, compute. So for T2, date 1, date 2, and the days between dates. Date 1 for T2 is December 12th, 2004. So 12/12/04. And date 2 is 06/06/05 still. So you can just stay in the days between dates menu and scroll up and change the date 1 to 12/12/04, enter, and then scroll down to the days between dates and compute. And you should get 176 days. Yeah. So now T2 is 176 over 365. Finally, T3, date 1, date 2, oops, and the days between dates. So if you've got date 1, which was what? September 4th, 2004. So 09/04/04. So many repeating numbers. 06/06/04. Weird. 06/06/05. So just changing date 1 to 09/04/04, enter. Scroll down to the days between dates, compute, I get 275 days. So T3 is 275 divided by 365. Now we can go in and say, okay, well, now we know the time for each of these. The last thing we're going to jot down is the rate. So it's 0.075 simple interest. So we have to use the simple interest formulas. We're going to find future value 1. Future value 1, they changed their minds. No, thank you. Is P times 1 plus R times T. In our case, it's going to be T1. P was the original value of the loan, which is 2,000 times 1 plus R, which was 0.075, and T1 was 113 over 365. And I've just got it here. I'll do it. 113 divided by 365 times 0.075 plus 1 times 2,000. 2,046.438356. So in money, it's 2,046.44. Moving on to future value 2 is P times 1 plus R times T2. P for future value 2 is 10,000 times 1 plus R, which is 0.075. And T for this one was 176 over 365. 176 over 365 times 0.075 plus 1 times 10,000 is 10,361.64384. So in money, 10,361.64. Future value 3 is the last one. And so the future value 3, again, is P times 1 plus R times T3. P for future value 3 was 4,000 times 1 plus 0.075 times 275 over 365. $275 over 365 times 0.075 plus 1 times 4,000. 4,226.02737, which in money is 4,226.03. So the total owing is future value 1 plus future value 2 plus future value 3, which is, I'll ditch the dollar sign, 2,046.44 plus 10,361.64 plus 4,226.03. which is 16,634.11. Tedious, but not hard, right? As long as you have your calculator to find the days between dates, right? So you'll want to make sure that you have a calculator that you can use. I know they lend them out in the library, but all the business math sections are writing at the same time. So you'll want to keep that in mind if you don't have one yet. Okay. Any questions about that one? Not too bad. $19. So for 19, the question type, I would say, well, it's compound interest now, but also figuring out equivalent payments. So it's compound interest, equivalent payments. Or equivalent, I'll say / unknown payments. If we read ahead, what you'll see is that 19 and 20 are for the compound interest section. So that's just this section of your formula sheet. It's still on the front page, but 20, you're not allowed to use the the calculator functions. And so you have to do it by hand. But I think you'll find it's pretty reasonable. So for this one, I guess you could use your calculator for some of it, but when we're figuring out the unknown payment amounts, it's easier to just do it by hand, I think. So first thing we're going to do is just figure out what our timeline is going to look like. So we've got a contract and it requires payments of $3,000 and $7,000 made in 2 and 5 years respectively. What 3 equal payments made today, 6 months from today and 1.5 years from today, are equal in value to the original contract. And so assume that money earns 6% compounded bi-weekly. So what I'm going to do is I'm going to do the original contract, and then after that, below it, I'm going to do the new contract. But remember that kind of trick that we use so that it's easier to visualize things that are going on is that we put the times for all of the contract on both of the timelines. So you don't have to, but I think it makes it easier. So we need a tick at 2 years, 5 years, and then today, 6 months from today, and 1.5 years from today. So I've got 5 ticks total, 2 at the end points, and then 1, 2, 3. And in order, I've got today, I've got 0.5 years, right? Converting 6 months to just half a year, and then 1.5 years, 2 years, and 5 years. So the original contract said, okay, you're going to pay $3,000 at 2 years and $7,000 at 5 years. And then the new contract has the same timeline. Today, half a year, 1.5 years, 2 years, and 5 years. But now the new contract says, okay, what 3 equal payments, right? So if they're unknown payments, we just denote them with X. And we've seen scenarios where the first payment is an unknown payment, and then the second payment is twice the first payment and things like that. That could be as well. But in this case, we've just got 3 equal payments made today, 1.5 years, or a half a year, and 1.5 years from today. Okay. It doesn't say what to use as the focal date. Depends on if you like to calculate future values or present values, or maybe a little bit of both, right? Because their arrows are going to get drawn to the focal date, right? You have to figure out, okay, the original contract, what it's worth on some date, and then what your new contract is worth on some dates. So for simplicity, and because it's what I've got on here, I'm going to use today as the focal date, but really you could have picked any one of these because I didn't tell you which one to use. You will end up with the same payment amount, but it's just easier if we just use the same focal date. Pretty sure I've specified on the final exam what to use as the focal date. Pretty sure. Use today as the focal date. So that says, okay, we'll take this 3,000, figure out what the present value of that one is, take the 7,000, figure out what the present value of 7,000 is. I didn't give myself enough room here. The total of this is the total of the original contract. So what I want is I want X plus the present value of this X, which I'll call present value 3, and the present value of this next X, present value 4. These have to total the same total as the original contract, right? Otherwise, they wouldn't be equivalent payments. So the total of the new contract. So I'll start and I'll find, okay, well, we've got compound interest. So first compound interest problem, just highlight that here. So assume that money earns 6% compounded bi-weekly. So F is 26. For compound interest, we have to find I is R over F, which is 0.06 divided by 26. 0.00230762, which I'll store in 1. Because I know I'll need it. Remember when we just had compound interest and we didn't have these regular payments, right? Then N was just the number of compoundings. As soon as you have regular payments, right? So some payment frequency, your N turns into the number of payments, right? But in this case, yeah, we have payments, but they're not regular payments, right? We don't have some payments per year, right? And so in this case, N is time times the frequency. Time in years is 2 times 26. It's 52. N is time times the frequency for the next one. The time here is 5 years. Remember, T is always in years. 5 times 26. It's 130. For the next one, we've got N is 0.5 times 26, which is 13. And then N is 1.5 times 26, which is 39. Now we have all the components to doing our calculations, right? As long as we keep track of which N goes with which present value and which future value goes with which present value, then we'll be safe. Okay. So present value 1, the formula is on your formula sheet, right? So we can just jump in and use it if we want to, is the future value over 1 plus I to the power of N. The future value for present value 1 is 3,000 over 1 plus 0.00230769 to the power of n, which was 52. One plus recall 1 to the power of 52, and then 3,000 divided by that. 2,661.129183. So in money, we got 2,661.13. On to the next one. Present value 2 is the future value times 1 plus I to the power of n. The future value here now is 7,000 over 1 plus 0.00230769. Remember I said, if you've told me that you've stored this I in 1 or whatever, if you just want to write recall 1, that's fine. But I'm just going to keep writing it out. N for this one is 130. So we've got 1 plus recall 1 to the power of 130. And then 7,000 divided by that is 5,187.520157. Which in money is 5,187.52. Present value 1 plus present value 2. That's going to be the total value of the original contract. So that's the total that we're working towards. But we're going to keep going and find our present value 3 is the future value over 1 plus I to the power of n. The future value here is just x. And so x, which we don't know, over 1 plus 0.00230769 to the power of 13. 1 plus recall 1 to the power of 13. And then 1 over that is 0.970479075 times x. I'm going to store this in 2 because I know I'll need it later. Finally, my present value 4 is the future value over 1 plus I to the power of n. My future value is x over 1 plus 0.00230769 to the power of 39. 1 plus recall 1 to the power of 39, and then 1 over that is 0.914025953 times x. And I'll store this in 3. Whew. Now we have all our present values. Keeping in mind, on this side, for the new contract, we've also got that x today, right? We didn't have to move that x, but we can't forget about it when we're adding up our total, right? And so we know that the total original contract must be the total of the new contract. which is present value 1 plus present value 2 must be equal to x plus present value 3 plus present value 4. Ugh. So we have 2,661.13 plus 5,187.52. Just double checking here. Yeah. Must be equal to x plus 0.970479075x plus 0.914025953x. On the right-hand side, we've got x's on each of these, so we can collect like terms, and we can say, okay, well, that was 1 plus recall 2 plus recall 3. So that on the right-hand side, I've got 2.8845050028x. And 2661.13 plus 5187.52 is 7,848.65. So x must be divided by, saved it, 2,720.96943. So x in money must be 2,720.97 cents. And you've seen one just like this on, well, practice test 2, on test 2. So all of these you've seen to some extent before. Any questions about that one? Okay. So we'll do this last one today, and then we'll save the rest for Wednesday. How about? Why not? As far as the type here, we're still in compound interest, right? There's no regular payments, so it's just compound interest, but it's compound interest that you have to do by hand. Compound interest by hand. So what's the value 1.5 years from now of the following payment stream using a 4.1% monthly compounded rate of interest? So this means that F is 12. A payment 1 year from today of 15,000 and a payment 6 years from today of 2,000. All calculations must be done without the help of the time value money functions of your financial calculator. Okay. So we'll start with our timeline. Again, we're just going to outline which dates we have to have on here. And so because all of these dates are referencing today, it's going to be easier to just have today on there. So 1.5 years from today, a payment 1 year from today, and a payment 6 years from today, but also I'm going to tack today on there to make 4 data points, or 4 little time ticks. So I've got today, and then 1.5 years, and then, oh, sorry, 1 year. 1.5 years. and 6 years. So the payment amount 1 year from today is $15,000, and a payment 6 years from today of $2,000. And we want to know what's the value 1.5 years from now, and that's what makes the 1.5 year point the focal date, right? We want to know what's the value at 1.5 years. So we can pull these to the focal date. The 15,000 goes to some future value 1, and the 2,000 goes to some present value 2. And this is the total value if you add those up. Kind of a simpler version of the question that we just did, also by hand. So not too bad. In the previous question, you could have used your calculator, sure, but the calculations are so simple that I don't, but you're welcome to. Okay, so on these arrows, right, we have to know our n, the number of compoundings, and so n is time times the frequency. The time between 1 year and 1.5 years is just half a year. So 0.5, and the frequency was 12. So we've got 6. And for the next one, the distance between 6 years and 1.5 years is 4.5 years times 12, which is 54. So you always have to keep track of, okay, it's the length of the arrow that I want for my time, right? Not the time ticks. Yeah? Okay. So, and if you didn't want the today tick on there, that's fine. It's not really doing anything except serving as an anchor, right? Because I want to have a reference point to today, but you don't have to have it on there. Okay. And we've got I is R over F, 0.041 over F, which is 12. 0.041 divided by 12 is 0.0034166. Probably repeating, but I'll store this in 1. Okay. So we have to find a future value and a present value. We've done worse. Future value 1 is the present value times 1 plus I to the power of n. Because we spent time on our timeline, right, we have all this information already. The present value for future value 1 is 15,000 times 1 plus 0.003416, repeating, to the power of n, which is 6. So 1 plus recall 1 to the power of 6 times 15,000 is 15,310.13856. 15,310 and 14 pennies for rounding properly to 2 decimal places. We can find present value 2 is the future value over 1 plus I to the power of n. The future value for present value 2 was $2,000. So 2,000 divided by 1 plus 0.0034166 repeating, to the power of 54. 1 plus recall 1 to the power of 54. 2,000 divided by that is 1,663.562941. Rounding to 2 decimal places, we get 1,663.56. So then the total value at 1.5 years is future value 1 plus present value 2, which was 15,310.14 plus 1,663.56, which is $16,973.70 even. Okay. Any questions about those ones? No? So go back and look at your test 1 and test 2 and figure out, okay, well, we've seen all these questions before, right? Figure out where you've seen them and try to get a handle on them. And then try to work through 21 through 24, but we'll go through those together next day. We're just gonna keep working through these. Okay. No questions? If you didn't get your test, come and get it. And if you want to sign up for that review session that I talked about, the sign up sheet is here. Otherwise, see you on Wednesday.